Hello everybody. After a long summer vacation, we are back to our work. We were doing electrophilic substitution reactions of phenol. The last reaction which we have done, it was sulfonation of phenol. Now the next electrophilic substitution reaction is coupling reaction. The topic is involved in 12th. It is for JEE as well as for NEET. Let's look what that reaction is. In this reaction, our phenol, this is phenol, is going to react with this compound. This is very well known to us, benzene diazonium chloride. Benzene diazonium chloride. And this is our phenol. This reaction will be carried out in the presence of base. The pH level will be maintained 9 to 10. Means a basic medium is required to perform this reaction. What will happen? This benzene diazonium chloride compound is going to join this phenol on para position like this. And side product will be HCl. The product generated here is known as 4-hydroxy azobenzene, or you can call it para-hydroxy azobenzene. The color of the compound is orange and it will be a dye. An orange dye will generate in this reaction. Now, why first of all the naming? This is azo functional group and this is OH functional group. Here main functional group will be azo functional group. So priority will be given to it, one number to it. Then 2, 3, 4. Means OH functional group is working as a side functional group. So we will call it hydroxy. Position 4. 4-hydroxy. And this is azo group connected with benzene. So azobenzene. So IUPAC name will be 4-hydroxy azobenzene. When OH group is working as a side functional group, its name turns to hydroxy. Or you can call it para-hydroxy azobenzene because it is on para position of the azo group. So common name will be para-hydroxy azobenzene. Color of the compound will be orange. Now some physical states. Phenol, which will work as colorless liquid here. This compound, it's a colorless solid dissolved in water. This benzene diazonium chloride will be a colorless solid. You have to dissolve it in a water while performing this reaction. Base, you can use NaOH aqua or KOH aqua. And the temperature of the reaction will be maintained 0 to 5 degrees Celsius. Note down these points. Why 0 to 5 degrees Celsius? Already I have discussed benzene diazonium chloride with you, that benzene diazonium chloride is highly unstable compound. If you will increase temperature beyond it, it will decompose to nitrogen gas. That's why to keep it in this form, we need to keep our temperature in lower condition. This reaction is known as coupling reaction. Now first, up to 12th level, how we can learn this reaction? Very easily we can learn this reaction. Let's start. This is phenol, and this is benzene diazonium chloride. This nitrogen carrying positive charge because it is making 4 bonds. Out of these 4 bonds, one bond is coordinate bond, dative bond. That's why it is carrying positive charge. This positive charge will be balanced by Cl negative. Benzene diazonium chloride it is. This nitrogen have a lone pair, and you know this is phenol, and phenol contains benzene ring, and benzene ring is a source of electrons. Pi electrons are available there, and in phenol, due to resonance of oxygen, the electrons are mostly available on ortho and para position. In previous videos, everything already we have discussed. So these ortho and para positions are high electron density positions, and here this nitrogen is carrying positive charge, and here we have electrons. But wait, don't think this nitrogen will attack on electrons. This nitrogen have a positive charge, but it can't attack on electrons because it can't make bond with them. It do not have any vacant orbital on it. This benzene diazonium chloride is all the time showing this resonance. Pi electrons sometimes shifted toward this nitrogen, and positive charge of this nitrogen is finished, due to which this nitrogen will carry a lone pair and it will become neutral, and 2 bonds will be there. Now this nitrogen is losing its electron. This electron was of this nitrogen, it is losing it. So on it, vacant orbital with a lone pair, a positive charge will develop. This is the resonance of benzene diazonium chloride, and this positive charge will be balanced by Cl negative. Between nitrogen and this Cl negative, we have an ionic bond there. So don't think they are making a proper covalent bond. A vacant orbital will be generated. So it is in this form. Now this nitrogen with a positive charge and with a vacant orbital is able to attack on benzene ring for electrons. This nitrogen can't do it. No doubt it have a positive charge, but positive charge doesn't mean it have a vacant orbital. This positive charge is due to the coordinate bond made by it with this nitrogen. That's why it is carrying a positive charge, but it do not have any vacant orbital. But look, this nitrogen have a positive charge as well as a vacant orbital. That's why it have a tendency to attract electrons in these vacant orbital. And who is going to provide electrons to it? A benzene ring of phenol. And which positions? 2 positions are ready for it, ortho and para. Para will be the major attack, because we know if this compound will attack on ortho position, steric hindrance will be there, because very big group it is, and OH is there, so repulsion will be there. That's why this group will not prefer to attack on ortho position, it will prefer to attack on a para position. That's it. You just need to join it here and complete the compound. Join this nitrogen like this nitrogen vacant orbital, join it here. That's it. Positive nitrogen, here we have electrons, join it. Rest points you can understand only when you will perform the mechanism part. And you know, here we have a hydrogen. Obviously this hydrogen will be replaced by this nitro group, this azo group, and hydrogen will release out as H positive, which will be balanced by this Cl negative. That's why side product will be HCl. So this will be para hydroxy azobenzene, a main product, orange color dye with a side product of HCl. Up to 12th level, you can understand this reaction in this fashion. No need to understand here what is the role of base here. This you will understand when we are dealing with mechanism. Let's start mechanism now. Up to 12th level, the mechanism is not in the syllabus. It will be for JE and NEET. Let's start the mechanism now. Role of base. What base is doing here? We have used NaOH, aqua, or KOH aqua as a base there. So you know what base will give us. They will provide us OH negative. Like KOH is there, so it will break in two parts, K positive, OH negative. NaOH is there, so it will also break in two parts, Na positive, OH negative. Now these OH negative ions, what they are going to do? Check. You know this is phenol, and phenol is slightly acidic in nature. How? Already we have discussed acidic properties of phenol. This hydrogen which is connected with oxygen, due to high electronegativity of oxygen, electrons are transferred toward oxygen side. That's why this hydrogen is losing the control on its electron. So it is carrying strong positive charge, and this oxygen is carrying strong negative charge. Two lone pairs already there on oxygen. Now this strongly positively charged hydrogen can be attacked by OH negative. It's a base, and this hydrogen is working as a acidic hydrogen there. So they will react between oxygen and hydrogen, bond will break, and when bond will break, obviously the both electrons will transfer toward oxygen, and oxygen will become this complete negatively charged oxygen, because one electron of hydrogen it will get extra. Now your phenol will turns to phenoxide, and what will release out from here? H2O. Water molecules will release out. This is the role of base here. Base is converting phenol into phenoxide ion. Now why we need to convert phenol into phenoxide ion with the help of base? Reason? Check. Actually, what is the problem? You know, we want attack of benzene diazonium chloride on benzene ring. Means this benzene diazonium chloride should work as an electrophile, because benzene ring is a source of electrons, pi electrons, and obviously the substance which is attacking on a benzene ring, it is looking for electrons, and the particles which are looking for electrons, we call them electrophiles. But the problem is it's a weak electrophile. It's a weak electrophile. Weak electrophiles are not properly attacking on a benzene ring for electrons. They do not have that capability to attack properly on the benzene ring for the electrons. So what we are doing, we are converting this phenol into phenoxide ion, due to which what will happen? This oxygen of a phenoxide ion will show resonance better than phenolic oxygen. This is phenolic oxygen. You know it will also show resonance. And this is phenoxide oxygen. It will also show resonance. Who is showing resonance better? Already I have discussed with you. Phenoxide ion can show resonance better as compared to phenol. Due to its better resonance, the benzene ring will be strongly activated by the electrons delivered by O negative. So due to resonance, what will happen? You know that what resonance will happen here. Oxygen out of 3 pairs, 1 pair it will shift here for the bond formation, only 2 pairs will left, and its negative charge will finish, because one electron, this electron, it has transferred toward carbon, and when these electrons will come here, these pi electrons will feel repulsion and they will shift to next carbon like this with a negative charge on this carbon, because this electron extra which is coming on this carbon. This is resonance. Resonance we know very well. And then this moment. Already we have discussed these points in previous videos. this will happen. So you can check the electron density is increasing on ortho and para position. Phenol can also do it. This phenol particle can also do it. But the problem is when it will show this resonance, when you will make resonance of a phenol, normal phenol, double bond, positive charge will come on this oxygen. No doubt lone pair here, negative charge here, and further movement but oxygen is carrying positive charge. Positively charged oxygen is highly unstable. So due to donation of electrons in the resonance, this oxygen is carrying positive charge, it is getting instability. That's why it will hesitate to show such type of resonance. That's why electron density will be less on ortho and para position. But you can check here, the phenoxide ion oxygen can deliver electrons easily, because after that delivery, this oxygen is becoming neutral. So it do not have any problem to deliver the electron. That's why benzene ring is getting high amount of electrons, and this benzene ring will be highly activated with electrons. Now, in this highly activated benzene ring, even weak electrophiles can attack easily. That's why we are converting phenol first to phenoxide ion with the help of a base. This is the role of base here. If you are using directly phenol already have a less electron density in the benzene ring, because for that oxygen have to show resonance, which is making it unstable. That's why this oxygen will hesitate to deliver electrons in the resonance like this. So less electronic density will be there. Okay, electronic density is less, and here in front of them we have a weak electrophile, so their reaction will be very, very difficult. Weak electrophile, less electron density, the reaction will become very difficult. So first we are converting this phenol into phenoxide ion with the help of a base. Now this phenoxide ion oxygen can deliver electrons very easily. That's why benzene ring will be highly activated with electrons. Now two positions are ready, ortho, para, and this electrophile will choose which position? Para position, because if it will attack on this position, steric hindrance problem will be there. This is the reason, and this is the role of base there. Now what will happen? Check. Once we have generated phenoxide ion, this is our phenoxide ion. Please keep in your mind H2 is already released out. Now this phenoxide ion will be attacked by benzene diazonium chloride particle. This is the condition of benzene diazonium chloride, but in this condition it will not attack. Its resonating condition will attack on it. What is the resonating condition? Obviously this nitrogen for stability will bring electrons toward itself, due to which in turns this nitrogen will carry a vacant orbital and a positive charge, and this nitrogen will carry lone pair, because this pair will shift here, and this nitrogen has lost one electron, so vacant orbital, positive charge. This positive charge will be balanced by Cl negative, but between Cl negative and nitrogen there is no perfect covalent bond, vacant orbital is there. Now we know due to resonance electrons are present here, hydrogen is there, so we'll attack on it like this. Para position will be attacked. Now vacant orbital, and for bond formation 2 electrons are required. This nitrogen do not have any electrons for the bond formation, so the responsibility will be of this carbon. How? It will shift these pi electrons here, and these pi electrons it will use to make dative bond with this nitrogen. So the next condition generated will be like this. Now when these 2 electrons, this carbon will be used to make dative bond, so out of these 2 electrons, 1 electron, this electron, it will completely transfer toward this nitrogen which have a vacant orbital, so the vacant orbital of this nitrogen will be finished, and 1 electron it will keep itself toward itself here, So the positive charge of nitrogen will finish because it is getting one extra electron, but problem will be for this carbon. A positive charge will come over it because it has lost its electron. This electron was of this carbon, vacant orbital, positive charge will come there. So how to stabilize this positive charge? And this compound which is generated here, this is a carbocation. We call it arenium ion, or sigma complex you can call it also. Sigma complex intermediate. This one. Now, in previous mechanisms, I have already told to you, this positive charge, this is a vacant orbital, this is a carbocation which is generated due to this carbon. Now this carbon will again help it. How? By breaking bond from hydrogen. And obviously when it will break bond from hydrogen, both electrons it will shift here, and between this carbon and this carbon bond will generate, and from here what will release out? H positive will release out. This H positive will be satisfied by Cl negative. So they will release out as HCl. And when these sigma electrons will be shifted here, so the compound generated will be finally bond will generate here between this carbon and this nitrogen, dative bond. This molecule as it is, and here we have O negative. Now you will think how this O negative will be satisfied. Very easy. This HCl which is generated here and water molecule which were released out here. So you know water molecules can deliver H positive, OH negative. Acids can deliver H positive, Cl negative. So these H positive, any H positive can satisfy it finally to convert it into OH group. This one. How bond will generate? You know H positive contain vacant orbital and this oxygen is carrying extra lone pair. So lone pair, vacant orbital, dative bond will generate like this. Due to dative bond formation, one electron is completely transferred toward hydrogen, so the negative charge of oxygen will finish, and as this hydrogen is getting one extra electron, so its positive charge will finish, and one electron it will keep with itself. OH is generated. This compound which is generated here, which is known as para-hydroxy-azobenzene. Azobenzene, side product HCl and H2O. This one. Color orange color dye it is. So this was the mechanism of the coupling reaction. Thank you very much for watching the video. Now in next video, next electrophilic substitution reaction of phenol we will discuss. Thank you very much.